Welcome, students, to another lesson with Mr. Kinnett here. This is our final section of Chapter 8 in our textbook, where we're going to be learning to solve multi-step equations and inequalities. And we're going to learn about some interesting solutions that can happen now that we have variables showing up on both sides. So go ahead and pause here and copy down what you see. Okay, welcome back. So again, we're working on solving multi-step equations and inequalities. And really the focus in this lesson is going to be on two strange answers that may happen since we have variables on both sides of the equations and inequalities. What is going to happen in this lesson? It won't always occur, but it sometimes could happen, so we got to be aware. Our essential question is, what are solutions for equations and inequalities that have no variables in the final step? And we're going to see what happens here. So you may have noticed that how we solve any multi-step equation or inequality, the steps have not changed. It's still Piam. Still Piam. Yep, not Palalam. Remember, we split up our L step into two different L steps. And that's going to lead us into our next slide here. And again, I'm going to ask that you copy down what you see. Go ahead and pause. All right, welcome back. Okay, so the two funny answers that may show up in an equation or an inequality that have variables on both sides are the solutions, all real numbers, which we also may call infinite solutions, and no solution. And this happens whenever we solve for equations or inequalities, and the variable is eliminated out of the final step. And it's going to be vital that no matter what we do, we make sure that we did our math right and that the variable did, in fact, was supposed to disappear. It just went away based on how the math was written. So in the end, if the variable disappears and the final line looks something like 5 equals 5, that's a true statement. So if the statement at the final line when the variable disappears is true, we're going to have the answer all real numbers. Okay? So again, if the statement's true, our answer will be all real numbers. And we have a way of writing that. We'll write the word all. And then this is actually a way of writing real numbers. It's kind of like an I and an R connected there, and that's the symbol for all real numbers. So that's what our answer will look like if the variable has disappeared and we end up with a true statement on the final line. If we end up with a false statement on the final line, so it could look something like -3 is greater than 0, then, if this happens, if the variable disappears and we end up with a false statement, then it turns out that the problem created actually has no solution. And what we're going to have to do whenever there is a no solution to a problem, we're going to draw a circle and then put a slash across the whole circle. That's not a 0. 0 is a number and therefore an answer. This is a circle with a line through it, and it stands for no solution. Okay, so our two funny possible answers we can end up with all real numbers or no solution. And let's go start seeing how this could happen in our mathematics. Go ahead and copy or pause here and copy these two problems down and realize you're going to need some space because these problems are not short. None of these Payam problems are going to be short. So go ahead and copy down what you see. Okay, welcome back. So we're going to start with number 1, and I'm going to switch the location of some slides here just so that we can see the steps at the same time. Okay, so step 1, we're going to draw our vertical line on our equal sign. And then step 1 says we do the distributive property. So we have the distributive property. Here we're distributing -2 times 3, which gets -6. -2 times positive r is -2r. And the right side has no distributive property. So we just bring the equal side down and the other things down. Okay, the second step is to combine our like terms, and we split it up into two L's. So the first L is each side. So remember, that's like two different simplifying expressions. The left side is the same thing. We're not going to do anything. The right side have like terms. We have a -5r and a -r. What's negative 5r plus negative r? Yeah, you're right. Negative 6r. Minus 8 has no friends, so it comes straight down. Okay, now we need to combine like terms across the equal sign, across that symbol. And remember, we're talking about the variables, and the smaller variable is the negative 6r. And we're going to use its additive inverse to get it across. The additive inverse of negative 6r is, yeah, plus 6r. And we have to be fair. So we got negative 6 plus 4r equals negative 8. Okay, now we're on our additive inverse step. Plus 6 plus 6 negative 2 equals 4r. And then we have our final step, that multiplicative inverse. Reciprocal of that is 1/4. And it turns out the answer to this problem is going to be r equals 1/2, I think. I'm going to get some more space real quick. Okay. Yep. So we reduce here, and that r, a positive and a negative is a negative 1/2. Oh, well, we got an answer. And the reason I actually started with this problem as an example is I'm trying to teach you that these special solutions of no solution and all real number do not happen a lot. So one more time, these special answers of no solution and all real numbers do not happen a lot. But it is possible for them to happen. So let's look at number 2. We're going to draw our line and start following Pion. First step, we got our distributive property. Left side has nothing to distribute, so we're bringing it straight down. Right side, we're distributing the 4. That gets 32 plus 8w. Okay. We have no like terms across the symbols, but we do have like terms, the variables, that we have to bring from one side to the other. Which one's smaller, 8w or 8w? Yeah, they're the same thing, so it doesn't matter which one I'm carrying. I'm going to write this one. And we got to be fair. And whenever we do that, 14 plus 0 would get you 14, which equals 32 plus 0, which equals 32. What is going on? Where did the variable go? Oh, wait, this is strange. Strange answers can actually happen. So I'm going to bring that slide back so that we can see them back together here. So let's first off, whenever this does occur, you're going to always double check you did your math correctly. So I distributed my 4 times 8 got 32, 4 times 2w got 8w. I did my additive inverse of minus 8w on both sides, and yep, the variable has been eliminated. It's disappeared. So is our line right here, is this a true statement or a false statement? You're right, it's false. And since it's false, the answer to this problem, turns out there is no answer to this problem. No solution is possible for this problem. No matter what number we choose for w, this problem will never work. So the answer to this problem is no solution. I got one more slide here. So if you don't mind, copy down questions 3 and 4, and we'll do those in class. So again, what we're learning here is we're still using Pion, but we're learning some special situations that may happen rarely when the variable disappears. It can end up as all real numbers or no solution. So again, copy down 3 and 4. We're going to do those problems in class, and I'll see you soon.